Hello everybody, here's Mr. C. This is a YouTube recording to help you with the honors project about solar power. Getting a nice warning here. Let's switch over to the sketchpad here for a second. I want to give you a high-level overview and I apologize right away my drawing skills here. The project has several parts and I do not know why it hopped back now. Bring that back here. So it has to do with analyzing solar power, and I changed the project from previous years to make it more personal to you, to work with your own data. In the past we had to do some sort of defined locations, big cities, Chicago, something that you don't have a relationship. This time we're going to analyze your own house basically. Let me sketch here good as I can California, and here we're going to go down to Texas now, and there's the Gulf of Mexico. Oh, I messed up New Orleans. Here's Florida. We go back up on the East Coast and make here the big lakes, right? And this is about as good as I can make a sketch for the US. And down here, of course, we have somewhere our California. And I drew this because we're gonna analyze where you live. So you're gonna live somewhere. I just pick a house somewhere or an apartment. This is where you live, and in your first part you need to gather data. You need to find the data for your house or apartment. And with what I mean with that is you need to find data on a monthly basis for your consumption of power. It doesn't matter which source it came from. Currently it comes either from hydroelectric, coal, or from nuclear, and to a certain extent from solar already. But you need that. So for each month I need basically a table. Here's the month. Here's month 1, 2, 3, and so forth. We need to know how many kilowatt hours you consumed per month. So this might be like 500 here, then 550, and so forth, right? So we have a table of that, and this is so kilowatt hours. I would have written here kilowatt hours per month, right? Then we need your how much you charge, how much you pay. Sorry, the cost is dollars per month, right? So maybe you find the billing statement. I'm now scribbling in there. Maybe you paid here $60, here maybe 67, and whatnot. And we're gonna make out of these two columns another one. I'm moving over here now, where I want you to get a feel of how many cents per kilowatt hour you're paying. You're gonna graph these three columns, of course. The last one here is might be helpful if you do the extra credit, where I want you to look a little bit more into cost. But I just want to get you a feel of here how many cents this is, right? So 600 cents divided by 500 is about 12 cents per kilowatt hour, right? And so whatnot. This is an important number. This drives, can a new technology like solar compete, right? How many cents per kilowatt hour do you pay for that versus others? Okay, so this is for your own location, and we're talking about, of course, the sun. I should have drawn that, of course, down up there somewhere. Sun is heating up everything, right? Go back here. So you're gonna get the table and you're gonna make me 3 charts, right? Here is time always. One time is the power here, the kilowatt hours per month, and you're gonna chart that. Then is another chart, time versus the dollars per month, and you do another chart, the cents per kilowatt hour time on the x-axis. So that's the first part. The second part then is to find out how much solar energy can you harvest at your location. So we want to find out if you were to have 2 types of technologies, and one is called solar concentrating power, SCP, and the other one is photovoltaic power. The solar concentrated power is basically a way to harvest thermal energy from the sun with mirrors and lenses, and then transfer that energy over to something that stores the energy. These days it's often salts, and you convert it later on to electricity. And photovoltaic uses semiconductors to create power directly. You're going to have access to what's called insolation maps. Insolation maps, and I'm going to bring one up here, and I hope I can draw on this thing. And I hope all these things is working. All these things are working. So for each month, you're going to have an insolation map, and you're going to find your location, right? You will put your house here. So what you have to do is, and unfortunately I didn't show you the legend there. I want to show you that too. I apologize for that. How do I make this thing bigger? Here I go. And hopefully it does it now here too. Yeah, okay. So I wanted to show you, here's the legend on the right hand side. So you're going to play approximately where your house is, where your location is. Even if you live in an apartment, you probably pay power. And this might be for January. Yeah, it is actually for January. So you have these maps for each month of the year. And you're going to go to your location, and you're going to find, okay, this is this orange type thing. So yellow is probably, the thicker orange is here, the yellow is here. So it's probably this guy. And don't make a science out of it. And then you use the average, right? It says 6 to 6.5, 6.0 to 6.5. Yeah, let's use 6.25. 6.25, and the units are very interesting. And let me remove them. The units are shown here, up here, in kilowatt hours per meter square per day. This whole thing is basically per day. And so you're going to create a table here again. Here's your month, and you're going to have a map for January. Here's your first month. For your location, you're going to get this solar insolation, it's called. I don't think it's written on here. Data is kilowatt hours per meter square per day. So kilowatt hours per meter square. I'm going to write it like this, per day. And you're going to write just the numbers in here, so 6.25, okay? This would be the starting point. And you're going to do this for each of the months, 1, 2, 3, 4, and so whatnot. And then you're going to convert these per days over to per month, because we want to compare monthly values. That's a choice we can make. The per day data is much, then you deal with 365 days. We can deal with 12 months, okay? But we need to convert it over to per month, so we're going to multiply this by, let's be friends, 30, okay? Multiply these values by 30, and then so we get here the kilowatt hours per meter square per month. Should write it like this. That we can now compare to what we really need, right? You're going to do this maps for both. Here you have it for photovoltaic, but you also do it for solar concentrating power. This is purely going, you're going to go through each month there. You're going to have that website, and you should use the more recent data on this website. Oh, now I'm in drawing mode. On this website they have, okay, here we go, and I see if I can, then I can't scroll, okay. Let me see, the more recent data is here, the 10 kilometer square data. Just pointed out, I hope, well, I can't draw on it, but I think you see it here. So there are these maps here from 1998 to 2005, and they are 10 kilometer squares. Okay, so each pixel there is 10 kilometers square. So go through those that are 10 kilometers square, the more recent one. Here you have it for PV as well as concentrating solar power. I might have flipped it around. Solar concentrate, I think SC CSP, it's called CSP. You're right. And so you use these maps here. I click on one of here where you are to find as good as you can. You can zoom in a little bit your value and go through one after another. Okay. Guess what? You're gonna graph those things too, and that's your second big part. I'll just use this now here. Second part, you're gonna do this. On the third part, you're gonna study how these power plants work. You know, what are the technologies used? Are there latest salts? Give me examples of it. Give me an explanation and how the energy gets transferred from the solar collection over to heat transfer and to electric power generation. Oh, I turned on inking here. I'm really fancy today. I can write directly on the Word document. And the same you do for the photovoltaic PV. You find a lot of data there. It's a bit more interesting here because that's what you see widespread use. You see the photovoltaic cells all over the place. Now, the next part is to do the calculations of the power. So you have the monthly power from part 1, your kilowatt hours per month, and you have the kilowatt hours per meter square per day converted over to per month now, and you can divide this value here by this value here, and then the meter square will become the numerator, and that's what we're looking for. So create another table here where you're going to find now the area that is needed to supply the amount of power for your house, for your location. Okay, it might be, you know, how many square meters of solar cells, how many meters square of these concentrated solar power plants would you need? Okay, and then you graph them. Try to graph them both on one figure here, but you can create two of them if you struggle with that. All right. So then, while you do actually for number 6 is this would be just pure calculation. Number 6 is an interesting add-on, only worth 8 points, but it requires you to go back, and you might want to do this right away when you look at the solar installation maps here. Look at areas in the US that have the highest and the lowest insolation values. So in other words, while you go through the months on this map here, bring that map back up. I don't know where it went. Did I close it? It's gone. And well, bring it back up here. Clicked on one of them. Yeah, here it is. Bring it back over here. Oh, snap. Reload. What's that? Don't give me a snap here. All right. Again, I don't want to use feedback. I want the map. All right. I hope that works. So let's stick within the continental US. So you know, when you have a certain month, I didn't pick a month here. I picked an average something, but it's your choice to find an allocation that has to be the same location through the 12 months, right? We cannot move the plants around. But say, hey, I see this thing when you look through the maps down here, this corner is always high. So then you want to know how high is high. You're going to keep track of it as a function of time. In maybe the original table, you know, it's greater 6.5. So then use 6.5, right? If it's smaller than 3, use 3. But you want to know, hey, if I look through all these maps, or maybe you use the one that has the whole year there and find the location and then track that amount that you can get there, right? Is it maybe up here is, you know, this would be the worst case, would be like I think maybe in Washington up there it's pretty light, it's raining a lot, right? So I would have a 3 up in Washington, and I would have probably a 6.5 down, maybe in the Mojave Desert here in Arizona, in California, or down in Arizona. Okay, so then you have these extreme values, and you should, in this short prompt for number 6, you discuss if you were to be living with your house in that area, needing that amount of energy, can that be supplied, given that you have a certain solar insolation coming from PV or CSB at that location. Okay, so or you could always go the other way and say you stay at wherever your house is, and you're buying the power that is produced at one of these two locations, where it's the most effective and the least effective to produce solar powered electricity, right? I have some extra credit down here, some extension. So the analysis was based that basically the 100% of the insolation got converted to electrical power. There are losses on the way, right? So this is not the efficiency of photovoltaics and so forth, but it's there's always losses on the way. What if you lose 50% of your energy? What happens then? Can you? How big is the area now that would need to be maybe plastered with solar cells? You know, have a reasonable discussion there, but use numbers, use values, make an argument. That's more important than the absolute numbers here. And the second one is you bring in the cost. Do some Google search, find out how much maybe, let's say now you know I need 20 square meters of solar cells to power my house on average. Do a little research and find out how much would it cost to do that. Not too hard, but I want real data there, not just explanations, qualitative. I want quantitative numbers to show me that you did your research there. And please cite your sources. And that's about it. If you struggle with finding data, let me know. I can help you out there. It's very interesting to look at it. I have something I will show you on Friday in the Class Connect sessions. I'm currently extracting my data from my house. I can share it with you. But I hope it's a fun project. It's like the first time I modified. There must be some questions you have. Please send me your questions. I try to make it better over time. That having said that, I'm also very lenient in grading. So as long as you give me an argument, right, hopefully supported with data, you know, what is it? Claim, evidence, reasoning. You know, you give me your claim, you show me data, and you give me a rationale. I'm happy with it. But I hope you enjoyed it, and it's going to be valuable when you talk to your children maybe in the future. You know, whether you should have put the solar on your roof or not, and it's, I think, a good knowledge you might find useful even outside school. So looking forward to seeing your work and working with you, making this project successful. Thank you for watching.